Good afternoon, friends. In last lecture, I discussed the few part of classification of disinfectant. Today, we will continue the same part. Yes, in last lecture, I have covered the aldehyde, phenol, and alcohol. Next, that is halogens. The chlorine or the sodium, hypochlorite is generally used in water disinfectant or the water disinfection. Then this is a sporicidal agent and act against the spore forming bacteria. It is an oxidizing agent and react with enzymes of the cell. Then the mode of action of halogen, then they are oxidizing agent and cause damage by the oxidation of essential sulfhydryl groups of enzymes. Then the chlorine react with water to form a hypochlorous acid, and which is microbicidal. Then examples of halogen, chlorine compounds, for example chlorine, bleach, then hypochlorite, then and iodine compounds, for example tincture, iodine and the iodophores. Then we will see the application of halogen. The tincture of iodine, that is the 2% iodine in 70% alcohol. It is used as antiseptic. Then iodine can be combined with natural carriers. Then the iodine can be combined with natural carrier polymers, for example polyvinyl pyrrolidone. To prepare the iodophores such as povidone iodine. Then iodophores permit slow release and the reduced the irritation of antiseptics. Then for hand washing, iodophores, these are diluted in 50% alcohol and 10%. Then povidone iodine is used undiluted in pre and post operative skin infection. Yes, this povidone iodine is used undiluted in pre-operative and the post-operative skin infections. Then the chlorine gas is used to bleach water. Then household bleach can be used to disinfect floor. Then household bleach is used in stock dilution of 1:10. Then in higher concentration, chlorine is used to disinfect the swimming pools. In higher concentration, the chlorine is used for disinfection of swimming pools. Then 0.5% sodium hypochlorite is used in serology and the virology. Then used at a dilution of 1:10 in decontamination of spillage of infectious material. Then mercury chloride is used as a disinfectant. Then we will see the disadvantages of these halogens. They have few disadvantages. First, they are rapidly inactivated in the presence of organic matter. Then iodine is corrosive and it will corrode the stainless steel surfaces. Then next, that is heavy metals. The mode of action, the heavy metals are act by precipitation of protein and the oxidation of sulfhydryl groups, and they are bacteriostatics. For examples of heavy metals: mercury chloride, silver nitrate, copper sulfate, and organic mercuric salt. For example, mercurochrome and the merthiolate. Then we will see the examples of this. Then we will see the applications of these heavy metals. 1% silver nitrate solution can be applied on eyes as a treatment of ophthalmia neonatorum, that is Sirard's method. This procedure is no longer followed. The silver sulfadiazine is used topically to help to prevent colonization and the infection of burn tissues. Then the mercurials are active against viruses at dilution of 1s to 500 to 1s to 1000. Then merthiolate at a concentration of 1s to 10,000 is used in preservation of serum. Then copper salt are used as a fungicides. Then we will see the disadvantages of few disadvantages of heavy metals. First, the mercury chloride is highly toxic. Then second, these are radially inactivated by organic matters. Then next, that is oxidizing agent. It is also an oxidizing agent that react with protein and the DNA of the cell. A 5% solution in water A 5% solution in water is effective against bacteria and fungus. It is very effective in water system sanitation. Then high concentration, that is 10 to 30%, are effective against bacterial spores and viruses. Then it acts as an oxidant and attract on essential cell components as a DNA, lipid and proteins. Then we will see the mode of action. It acts on the microorganism through its release of nascent oxygen. Then hydrogen peroxide produces a hydroxyl. Then the hydrogen peroxide produces the hydroxyl free radical that damage the proteins and the DNA. Examples: germicide contain hydrogen peroxide and the silver compounds. Then application of this, it is used at a 6% concentration to decontaminate the instrument equipment such as ventilators. Yes, it is used at 6% concentration to decontaminate the instruments equipments such as ventilators. Then 3% hydrogen peroxide solution. Then the 3% hydrogen peroxide solution is used for skin disinfection and deodorizing wound and ulcer. 3% hydrogen peroxide solution is used for what? The skin disinfection and decolorizing the wound and ulcer. Then strong solution are sporicidal. Then there are few disadvantages of this. First, decomposes in light. Then second, broken down by catalyze. Then proteinaceous organic matter drastically reduces its activity. Then next, that is surface active agents. The mode of action of this, they have property of concentrating at the interface between the lipid containing membrane of they have property of concentrating at interface between the lipid containing membrane of bacterial cell and also the surrounding aqueous medium. That is interface between the lipid containing membrane and the lipid containing membrane of bacterial cell wall and the surrounding aqueous medium. Then this compound, that is surface active agents, have long chain hydrocarbons that are fat soluble and charged ion. These are water soluble. Since they contain both of these, they concentrate on the surface of membranes and they disturb the membrane, resulting in the leakage of cell constituents. For examples, these are soap or the detergents. And then the detergents can be ionic or the cationic, anionic or the cationic. Then the detergents containing negatively charged long chain hydrocarbons. This detergent contains long chain hydrocarbons called as anionic detergent, and this include the soap and bile salt. And if the fat soluble part is made to have a positive charge by combining with quaternary nitrogen atom, it is called cationic detergent. Yes, detergent containing negatively charged long chain hydrocarbon, then it is called as anionic. And if the fat soluble part is made to have positive charge by combining with quaternary nitrogen atom, then it is called as cationic detergent. This cationic detergent are known as quaternary ammonium compounds. Then the cetrimide and the benzalkonium chloride, it act as a cationic detergents. Then applications, they are active against vegetative cells. They are active against vegetative cells, mycobacteria and enveloped viruses. Then they are widely used as a disinfectant at a dilution of 1 to 2% for domestic use and in hospitals. But there are few disadvantages of this. Their activity is reduced by hard water, anionic detergent and organic matter. Then Pseudomonas can metabolize cetrimide using them as a carbon, nitrogen and the energy source. Then we will see the next, that is dyes. A number of dyes have been found to inhibit the bacterial growth. The basic dyes are more effective bactericides than the acidic dyes. The acidic dyes. The acidine and the triphenyl methane dyes are commonly used antimicrobial agents. The acidine and the triphenyl methane dyes are commonly used antimicrobial agents. Mode of action of these dyes. The acridine dyes are bactericidal because of their interaction with bacterial nucleic acid. Then examples of dyes. The aniline dyes such as crystal violet, malachite green and the brilliant green. The acridine dyes such as acryflavine and the amina green. Then acryflavine is a mixture of what? Proflavin and the euflavin. Yes, this acryflavine is a mixture of proflavin and the euflavin. Then only euflavin has effective antimicrobial properties. Then a related dye, ethidium bromide, is also germicidal and it intercalate between the base pair in DNA. Then they are more effective against gram-positive bacteria. These dyes are more effective against the gram-positive bacteria than the gram-negative bacteria and are more bacteriostatic in action. Then applications, they may be used topically as an antiseptic to treat mild burns. They are used as a paint on the skin to treat the bacterial skin infection, and the dyes are used as a selective agent in certain selective medias. Then next, that is alkylating agent. First alkylating agent, ethylene oxide. The mode of action of ethylene oxide. It is an alkylating agent and it acts by alkylating sulfahydryl, amino, carboxyl and the hydroxyl group. It acts by alkylating the sulfahydryl group, amino group, carboxyl group and the hydroxyl groups. Then properties, it is a cyclic molecule which is a colorless at room temperature. Then third, it has sweet ethereal odor. Then it is readily polymerized. Then next, that is, it is flammable. Then application of this ethylene oxide, it is highly effective chemisterilant and capable of killing the spores rapidly. Since it is highly flammable, it is usually combined with CO2 or the difluoromethane. It is usually combined with, since it is highly flammable, it is usually combined with CO2 and the difluoromethane. That is 10% CO2 and the 90% EU. Then it requires a presence of humidity. Then it has good penetration property. Then also it has, or it is well absorbed by the porous material. Then it is used to sterilize heat labile articles such as bedding, textiles, rubbers, plastics, syringes, disposable petri dishes, and complex apparatus. For example, heart lung machine, then respiratory equipments, then dental equipments. Then the efficiency testing is done by using the Bacillus subtilis vinegar. Then there are two disadvantages of this ethylene oxide. First disadvantage, it is highly toxic. Then second, it is irritating to the eye. Then third, skin highly flammable. It is irritating to the eye, then irritating to the skin. Then next disadvantage, it is highly flammable. Then it is mutagenic and the carcinogenic. Then next alkylating agent, that is capital BPL, that is beta propionolactone. Capital BPL, that is beta propionolactone. The mode of action, it is an alkylating agent and it acts through alkylation of what? The alkylation of carboxyl group and the alkylation of hydroxyl group. Then properties of this beta propionolactone. First, it is colorless liquid, then with pungent to slightly sweety smell. Then it is a condensation product of ketane with formaldehyde. Keep in mind what I am saying. It is the condensation product of what? It is condensation product of ketane with formaldehyde. Then applications of this beta propionolactone, it is effective furicidal agent. Then it has broad spectrum activity. Then 0.2%, that is 0.2%, is used to sterilize the biological products. Then it is more effective, or it is more efficient in fumigation than formaldehyde. Then it is used to sterilize vaccine. Then it is used to sterilize the vaccines, tissue grafts, surgical instrument, and the enzymes. And then disadvantages of this beta propionolactone, that is capital BPL. Disadvantages: first, it has poor penetrating power and is a carcinogen. So this is all about the disinfectant and the antiseptic. The next part of our syllabus, that is factor influencing on disinfectant. There are few factors that are influencing or that are affecting on the disinfection. This part we will see in next lecture. I will stop here.